to build upon what we did yesterday. And so yesterday we introduced synthetic division, and it is a way for us to identify the solutions to polynomial equations. Now we're only working with solutions right now. At this point, we're only working with real solutions. How do we determine what the possible real solutions are? So as a reminder from yesterday, please circle the constant, the number in back that has no x, and please circle the leading coefficient. In this case, it is a hidden 1. And so what we're going to do is we are going to list all of the factors of 18, and that means what numbers nicely divide into 18, both positives and negatives. So positive 1, positive 2, 3 nicely divides, 4 and 5 do not, 6 divides into it, 7 and 8 don't, 9 does, and 18 does. All over positive or negative 1. So it's really nice when the leading coefficient is a 1. When the leading coefficient is a 1, we know that we can easily identify these. We have 2, 4, 6, 8, 10, 12. We have 12 different possibilities that could account for these 4 real solutions. Again, now later today we're going to still get into real solutions, but they're not always going to be integer solutions. So they may be ugly and in a fractional form. And later on we'll get into imaginary solutions that are not real, but we're not there quite yet. So yesterday we talked about how do we go about doing this. So let's go ahead and let's do the first one. I'm going to have you just watch this first part. So I'm going to test a positive 1. If it works, I'll have you write it down. So I'm testing positive 1. So I'm looking to make sure that everything is accounted for. Notice that the highest exponent on a variable is a 4. So I have x to the 4th, I have x to the 3rd, I have x squared, I have x to the 1st, and this would be x to the 0. Now I know that this is a solution if the result in this box below or the remainder is a 0. So I'm going to refer to synthetic division using the acronym MAMA. So I'm going to multiply always back to this number. If you were here yesterday, it's like the magical number we multiply back to. So I multiply once I dropped on the first number. Multiply, add down, multiply, add down, multiply, add down, multiply, and we can see we end up with 0. I'm going to press pause and I want you to write this down. While you are writing this down in person, I know 1 works. I'm going to come up to the top and write x equals 1. Now at this point, I'm going to create another polynomial equation. 0 equals, and I'm working backwards. There's no x's, there's 1x, there's 2 x's, and there's 3 x's. And when I get to this point, I can ask myself, is it possible for me to use the method that is factoring by grouping? It's not always going to be possible, and we'll talk about what to do when you can't. But let's check to see. So before you write this down, let me make sure to see, does this work? So I'm looking at the first 2. The only thing I can factor out is an x squared. X squared times x gives us 1x cubed. X squared times 2 gives me 2x squared. You're only watching. So what I'm doing right now is I'm testing to see if one of the tools we've learned, which is we can solve using factoring by grouping, we're going to see if this works. What number times x is negative 9x? That's a negative 9. So that's negative 9x, and that is a negative 18. Go ahead and please write down what I'm doing. I know this works right now. It is a tool. Actually, you can sit over here. It is a tool that allows me to solve. So in the front and the back, we both have the group x plus 2. In front of the first parenthesis is x squared. In front of the back parenthesis is a negative 9. Notice that I want 4 solutions. And I've told you right now that we're only working with real solutions. So I want 4 solutions, and I've only identified 1 of them. Each one of these parentheses is called a factor. I'm going to set it equal to 0, and I'm going to solve. So subtract 2, x equals negative 2. Add 9, x squared equals 9. Notice that when I take the square root, I'm going to have 2 answers. X equals, the 2 answers are represented right here. Plus or minus the square root of 9 is 3. So if I'm going to list these, and we'll talk about what this means on a graph next week. These are my 4 solutions to this polynomial equation. If I plugged in positive 1 wherever I see an x and I did all the math, it would equal 0. Likewise, if I plug in 3 or negative 2 and I did the math correctly, it would equal 0. That's a review from what we did. Example number 2. Now, example number 2 definitely is increasing in strength. The first thing I'm looking for is I'm looking that everything's accounted for. So I'm already can see this is in standard form, and that the highest on a variable is a 5. We call this degree 5 polynomial. So I have 5, 4, 3, 2, 1, and 0. Nothing is missing. You are just watching. I'm going to circle the constant and I'm going to circle the leading coefficient. Whenever the leading coefficient is a 1, it makes it really easy when I'm listing out the possible solutions. Now, I'm going to be honest with you. Unless you're asked to list them all out, I'm not going to take time where this number is 140. Notice 18 is pretty easy. I can quickly do 18. 1, 2 factors, 1, 2, 3, 6, 9, blah, blah. 140, that's getting a little large. And so if I don't have to list them all out, I'm going to start by just knowing that I know 1 goes into this. I know 2 and negative 2 goes into it. You're going to sit back there by Abby. And so I'm going to start with 1, and you are just watching as I test this. So I'm going to come over here, and I'm going to test 1. If it doesn't work, I'm going to test negative 1. And I'm going to keep going until I find 1 that works. Testing 1. Here we go. I have 1x to the 5th. Negative 6x to the 4th, negative 28x to the 3rd. You're going to have a calculator out for me because what you're going to do is you're going to help me do the math process. So I don't have to stop here and grab a calculator. Okay, are you ready? So I am testing 1 right now. Testing 1. I drop down the very first number. And after I drop down the very first number, I'm going to start with the Mama method. So I multiply to get 1. I can do that in my head. I add down to get negative 5. I multiply to get negative 5. I can still do this. You correct me if you see anything wrong. I get a negative 33. I multiply to get negative 3. Now grab that calculator. Don't just sit there. Grab the calculator and please add 146 and negative 33. What do you come up with? Okay, I'm going to take 1 times 113. Please add 27 and 113. What do you come up with? 140. I'm multiplying again. I'm adding down and I get 0. Turn to your group. What does this mean? Turn to your group, not to me. What does that mean? It means whenever I get a remainder of 0, what I just tested works. So I know one of the real solutions is 1. But now this is where it's ugly. This is much larger than what I'm used to working with. So I'm going to write this backwards. I have 140, that's no zeros. This is I have no x's. This is 1x. This is 2 x's. This is 3 x's. And this is 4 x's. Okay? Confused. I know there's not much room here, but if you're confused, I asked you now to take this polynomial that's been achieved after I found out 1 works. So I have 1x to the 4th, right? 1x to the 4th. I have negative 5x to the 3rd, negative 33x squared, 113, and 140. And I want you to test right now on your own, and I want you to test. We tried 1. Let's try negative 1. I'm going to Does negative 1 work? Let's try. I'm dropping down and I'm multiplying. I'm adding and I'm multiplying. If you see you make a small mistake as I'm rushing, it's very possible. Please let me know. I'm adding down and I'm multiplying, and it works. So I'm going to come up here and identify negative 1. These are solutions. Again, what does that mean? Later we'll call them zeros on a graph, and we'll learn about that. It means if you plug in a 1 or if you plug in a negative 1 and you do the math correctly, we know we're going to get 0. So this is what I have left. I'm going to write this backwards. Okay, this has no x, this has 1x, this has 2x, and this has 3x. Now, I'm going to check because it doesn't always work. I'm going to check to see, can I go through the motions here, and can I possibly factor by grouping? Let's check. Out of these two, the most I can factor out is an x squared, and I'd have x minus 6. There's x cubed minus 6x squared. Now, I don't know if this is possible. Let's check. I don't know if this is possible. If I plug in a negative 27 here, I get negative 27 times x is negative 27. But what is 27 times 6? 27 times 6 is 162. Notice this. If I distribute a negative 27 times a negative 6, I get a positive 162, and I want a positive 140. What it tells me is that the trick of factoring by grouping as a method to solve does not work for this polynomial. So this is what I have right now. In your groups, I want you to work on problem solving. I'm going to press pause. I'm going to walk around, and I want to know what other numbers could you test right now. I would go through and I would start testing. This is what I mean by testing, and I'm trying 2. By the way, 2 doesn't work. and I'm trying -2. Is everybody listening to this? And I'm trying -2. And I'm going through the process of trying to identify. Now, remember that when we came up with, if we went through the list of possible real roots, I'm going, what can I factor? Sorry, what are factors of 140? So when I take 140 and divide it by 1, notice I get a nice integer, so I know 1 and -1 I could test. When I take 140 and divide it by 2, I get an integer, so I know I could test 2 or -2. When I take 140 and divide it by 3, whoa, I put a wrong symbol in there. When I take 140 and I divide it by 3, does everybody see how that doesn't work? Because I don't get an integer. So I would try 2 and -2. And I'm going to save you a little bit of time. I'll tell you 2 and -2 don't work. Okay, back to your group. This is mandatory. Back to your group. If 2 and -2 do not work, what would you see here? If 2 and -2 don't work, what would work? If this was a 2, what would be here? If this was a -2, what would be here? Any number except for what? 0. Any number except for 0. It may be positive, it may be negative. If I put a 2 here and I did the work, this would not be 0. It would be anything but 0. If I put a -2 here, it could be any number but 0. And when we get any number but 0, we know it does not work. So I'm telling you 2 and -2 don't work to save you time. We're not going to check 3 or -3. Let's try 4. Okay, 4 appears to work. Can everybody test 4 right now? And I'll do it at the same time. Let's all test 4. So I'm taking this, and now I'm going to show you where you can start to save yourself a little bit of time. Once you've identified that everything is here, what that means by is this is degree 3. So I have a place value for x to the third, a place value for x squared, a place value for x to the first, and a place value for x to 0. When that's done, you don't have to write x cubed, x squared, x behind it. We can simply write 1, -6, -27, and 140. Okay, here we go. Dropping down, and now I'm doing mama. I'm multiplying, and I'm adding down. I'm multiplying, and I'm adding down. And you guys are going to do this for me. That looks like it is 140, -140, adding down to get 0. So that tells me what? What does it tell me? 4 works. I'm going to come up here, and I'm going to write x equals 4. It works. And just like I did when -1 worked, I took this and I turned it into a polynomial. And I tried. I said, hey, can I solve this using a type of factoring, which was factoring by grouping? It didn't work. So then I had to go about doing synthetic division. Well, let's come down here and let's rewrite this as a polynomial. So no x is working from right to left. 1x and 2x. And now you know a few different strategies. One strategy is, hey, maybe factoring will work. When it doesn't, we got to figure out what to do. But let's see, does factoring work? What multiplies to equal -35 and combines to give us a -2. This tells me they're going to be different signs, and the larger number is going to be negative. And that is going to be what two numbers? 7 and 5. Larger number is negative. So I know this is going to be x plus 5 and x minus 7. Those are the two parentheses called factors. I'm going to set each one of these equal to 0, and I'm going to solve. And in doing so, I achieved answers of -5, and I achieved answers of +7. X equals -5, x equals +7. Here's our next question. So if you were just with me live in the classroom, or if you're watching this at home, this is the next example students were asked to do. X to the 5th plus 2x to the 4th minus 15x cubed, subtract 20x squared plus 44x plus 48 equals 0. So they were asked to solve this, and this is not using any type of graphing device. You can use a calculator on it, but not the graphing device. So I checked 1, it didn't work, -1 worked, okay? And then I'm going through the possible rational solutions, or rational roots they're called. I'm checking 2, it works, but I can't use this polynomial to solve using the grouping method. So then I check -2. And once I get to this part, I can rewrite it in this polynomial equation, which is actually quadratic, and I'm able to factor and solve. Okay, we're going to increase difficulty. Here's your next example. So this is example number 4 on your paper. I think it's the 3rd one. We have something missing here. What is missing? We are missing an x. So I'm going to rewrite this. So there's 1x to the 3rd, subtract 7x squared, plus 0x plus 20 equals 0. And now I'm going to start by circling the constant and the leading coefficient. And I'm going to write down all of the factors of both. So the factors of this last number called the constant would be positive -1, positive -2. 3 doesn't work because it doesn't nicely divide into 20. 4, 5, 10, and 20. And like I've said, it's very nice when the leading coefficient is a 1. So how many possible different things could we check? 2, 4, 6, 8, 10, 12. We have 12 different ones to check. 12 different ones to check. So let's get started. Now let's split this up, and immediately, as you know, you will tell us the answer. So please listen closely right now. I want all females to check +1, all males to check -1. I'm going to press pause. You are live with me in the classroom. Students have tested 1 and -1. They do not work, which means the remainder is not 0. We're going to move on to 2. Females, please test +2. Males, please screen feedback that 2 works. So I'm going to go ahead here. Males, sorry, you're doing a little more work here. I would like you to write down testing +2. So I'm going to come up here. Now that everything is accounted for, it's 1x cubed, -7x squared. I had to put a 0 here, or this would be wrong. 0x to the first and 20x to the 0. Okay, after I drop down the first number, I'm going to revert back to that MAMA method as an acronym. Always multiplying back here. Multiply to get 2, add down to -5. Multiply to -10, add down to -10. Multiply to -20, and I do have 0. That tells me that one of my real solutions is 2. Now I'm going to go ahead with what we see in the bottom, and I'm going to write down a quadratic equation. So -10 has no x's, -5 has 1x, and 1x squared. This is what I need to solve now. You have the tools to solve this. Naturally, the easiest thing to do is to say, can I factor what multiplies to give us -10 and combines to give us -5? Is that possible? It's not. It's not possible. I can't think of 2 numbers that multiply to give me -5 and also combine to give me multiply to give me -10 and combine to give me -5. So please write no factoring. We cannot factor. That doesn't mean we can't solve it. So what do you learn in 8th and 9th grade? How do you solve a quadratic equation? Anybody? Quadratic formula. Please write this down. I know there's some kind of song. I don't know it. It's probably a blessing for you that I don't know that song. I won't sing it. This is what we're going to do. We're going to plug in 1 for A. We're going to plug in -5 for B, -10 for C, and we're going to simplify it down. I absolutely need to see your work. So I'm plugging in right now, -5 for B. Wherever I plug it in, I put it in parentheses. And then I'm going to demonstrate how you can use a calculator to do the work after I've set this up. So I'm going to give you a second to set up what I've done. So all I've done is I've taken out the A, the B, the C. I've put in the numbers, and now I'm going to show you the value underneath the square root. We can grab a calculator for it. If you don't want to do the mental math, bless you, make sure that -5 is in parentheses, subtract 4 times 1 times -10. So I've plugged in what's called a discriminant. It's that value underneath the square root, and I end up with 65. Can I get anybody to confirm? Did anybody else get 65 there? Okay? So what do we do right now? We're going to keep simplifying. 2 negatives make a positive. So I have +5 plus or minus the square root of 65 over 2. Now normally we would say, okay, you're done, great job. But remember, at this level of math, you always have to see, can you simplify further? So I need to see, are there any perfect squares that divide into 65? So 64 is a perfect square because it's 8 times 8. 7 times 7, that doesn't work. 6 times 6, that doesn't work. 6 times 6, 5 times 5, that doesn't work. 4 times 4, and you're seeing that none of these work. 3 times 3, 2 times 2, and 1 times 1 doesn't simplify anything. This is our final answer. So when you need to list all of the real solutions, here's how it would be for this problem. One of them is x equals 2. So x equals 2, that's one solution. And watch, this is a mathematical way of being lazy. Because if you want to write it out the long way, you'd say, well, one time I'm going to add and get an answer, and then next time I'm going to subtract and get an answer. I am completely okay with you writing it one time and recognizing that you're going to have two different answers, one time adding, one time subtracting. A total of 3 solutions for this problem. Right now, we're thinking about what are the possible things. If you're like, well, what am I supposed to test? I'm not on my own. What am I supposed to test? Factors of 40. Now, if that's confusing for you, what this means is this. It means I'm going to take this and I'm going to go, okay, 40 divided by 1. It's a nice integer, so I'm going to test positive and negative 1. They're factors. 40 divided by 2. Well, 40 is even, so 2 is going to work. I'm going to test positive and negative 2. But notice, 40 divided by 3 does not give us an integer. I'm going to skip it. 40 divided by 4, it works. I'm going to test 4. I'm going to test 5. I'm going to test 8, 10, 20, and 40. These are the numbers. Hello? Do you need me or are you just watching? Okay. These are the numbers that we're going to test. So we've already tested positive and negative 1. It doesn't work. It means that if I plug this in on the left-hand side, I'm not going to get 0. Males, I want you to test positive 2. Females, test negative 2. I'm hearing that 2 works. So can I have you, even if you are a male, we're all going to test 2 right now. So let's put 2 down. Remember the shortcut is you have to make sure that everything's accounted for. My highest exponent is a 4. So 4, 3, 2, 1, 0. I have nothing missing. So this is in the 4 spot. This is in the 3 spot. This is in the 2 spot. This is in the 1 spot. And this is in the 0 position. And I'm going to check right now. I'm hearing multiple people saying that it does work. Okay, I'm dropping down. This is the magical number I'm multiplying. 2 times 1 is 2. I add down. 2 times negative 1 is negative 2. I add down. 2 times negative 17 is negative 34. Correct me if I'm wrong and I make any mistakes. 2 times 20 is 40. It works. Hey, thanks for finding that. All right, now here's what I don't want you to write down. I just want you to watch. Here's what I would do next. I would make this polynomial equation, and it's looking like this. Okay? And I'm asking myself, my first instinct is to say, I know I can factor by grouping, but can I apply that method to this? So you're just watching, and I'm testing. So here's what I have. There's x cubed. There's negative x squared. Awesome. I'm coming over here. What times x is negative 17x? That's a negative 17. But notice, negative 17 times negative 1 is not 20. What does that tell me? It tells me I can't use factoring by grouping. Sometimes you can. Sometimes you can't. What do we do then? We go back to testing numbers. Does negative 2 work? Anybody, did negative 2 work for boys that tried it? Or girls that tried it? Yes or no? Negative 2 did not work. Okay, so we've tried 1 and negative 1. It didn't work. Hey, 2 works. I'm writing down x equals 2. Now, people have tried negative 2. It doesn't work. Let's try right now. Do me a favor. Let's try 4. Let's try 4. If it doesn't work, we'll try negative 4. So we're taking this polynomial and we're trying 4 with it. I'm placing a 4 out front, and we have 1x cubed minus 1x squared minus 17x to the first and 20. And I'm testing it. Can anybody tell me real quick, does it work? It works. Okay, we got that, we've got that, we got that. Okay, here's my next thing. Please write down, you have 5 seconds to take this and to write down a polynomial equation. It happens to be specific, it's quadratic. Write down the equation. Now our automatic response is to say, can I solve this? Listen closely. Can I solve this using the factoring method? Do you guys know 2 numbers that multiply to give you negative 5 and combine to give you 3? Yes or no? Not possible. What do we do when we can't then? Quadratic formula. Go ahead. Beat me. Quadratic formula. X equals negative b plus or minus. Always using parentheses to ensure we're not making small mathematical mistakes. Give me 1 second, Chair. And then this is called the discriminant. I'm going to bring it up here. I'm going to put in parentheses 3 squared minus 4 times 1 times negative 5. All that looks beautiful. And I come back. Did anybody else get 29 on the inside? Okay. So this comes back to x equals negative 3 plus or minus the square root of 29. over 2. Now, yes, you would take to see, can you fit a perfect square? So you're going to divide this by 29 by 16, but I know that 29 is prime. That means the only numbers that divide into it are 1 in itself, so I don't need to check that. But again, you would see, can I take 29 and divide it by the smaller values that are perfect squares? That'd be 5 times 5, 4 times 4. And you're noticing that none of these work. 3 times 3, 2 times 2. So this is my final answer. So when I write down the final answers for this problem, how many answers am I supposed to have? That's my question. 4, and how many have I identified so far? Have I identified 4? There's one, but where else have I not put something down? I did the work for it, but what have I not actually identified? Does everybody see how this was a solution? Does everybody see this? I need to come back and actually show this. So when I went to this APSI training, that was like training teachers to help students pass the AP exams for pre-calculus, calculus, and Calc 2, one of the main things that they said is that half your test you don't get a calculator. And when you have to show your work, even if you show like this particular work, and we know that you know that this is a solution, if you don't actually go off to the side to identify things, they can't give you credit for it. So this would have been a mistake I made if I stopped right here by not saying x equals 4 as well. We have 4 solutions, and here's where they land.